Well, in the last video, we have seen the threads and multi-thread execution, part 1. In that part 1, we have seen what is process, what is task, and what is thread. And next, I have explained the importance of threads, why threads are required in the programming. Because in every programming language, the way we call the methods one after another, that execution is called as sequential method execution. Well, maybe C or C++, Java or C Sharp, Smalltalk, any language you take, Python, PHP. In procedural language, from one method, when you call other methods, method 1, method 2, method 3, method 4, all the methods are sequentially called one by one. Once first method execution is completely, then control will come to the method frame where the method 1 was called, and from there again the control will go to method 2, completes its complete execution, come back, then 3 and 4 and so on like that. Same thing happens in the Java programming language also. But point here is the importance of threads is methods by nature, they run simultaneously. They run sequentially, but not simultaneously. Threads methods by nature, they run sequential. Because of the sequential execution. And once first method execution is completed, then second method, third method, fourth method, and so on. The problem behind the sequential method execution is if any method execution gets delayed, the delay will impact, the time will impact on the second method's execution as well. Suppose and if one method executes for some 100 iterations, in each iteration, if the method delays for 100 milliseconds, 100 milliseconds into 100 times method execution. For every method at 100 milliseconds into 100. That much time one method execution will take until such a method 1 execution is completed. If method 2 doesn't execute, that not only method 2, similarly method 3, 4, 5, 6 and so on, other methods which are being called from the same method. So that will impact the overall application. In order to overcome this problem, we want same class written with 2 or 3 or 4 methods. We don't object. But we don't want one method's execution delay impact on other method's execution. We don't want one method's, if one method executes continuously without any interruption, then if second method executes, third and fourth methods executes without any delay in these method executions, no methods are having any problem. Because anyway, as much time as method 1, 2, 3, 4 takes time, method 1 anyway it need to execute, then method 2 will execute, the next method 3 will execute, the next method 4 executes. They'll continuously execute one by one. So they don't bother about the methods 1 execution. Method 1 execution gets delay, then the second, third, fourth, fifth and sixth methods will ask, why do we need to wait for the first method's delayed execution? If that time is given to second, third, fourth and other threads, these threads says we could complete our executions as much delay as method 1 gets delay, and we may even complete our method executions before method 1's execution. Why our method execution is getting delayed? Because of first method's delayed execution. So in order to solve that. In Java, we do multi-threading. So the ability multi-threading gives is simultaneous method execution. Methods, if called, they'll execute one by one. If the same methods are put into threads and threads are started, then they'll run simultaneously. Okay? For each method, if you write one thread and starts 2, 3, 4 threads, then they all will run simultaneously. From fourth thread to again 1, 2, 3, 4, again 1, 2, 3, 4, like that. This is called as round robin. Most of the simultaneous executions follow round robin pattern of execution. Round robin pattern of execution. So in this case, each thread will be executed for its own allotted amount of time. After that, control will be given to the second thread, third thread, fourth thread, and so on to other threads. Again, back to first thread, second thread, third thread, and so on. Like that. In this case, no method execution's delay will impact on the other threads. Before completion of one thread, other threads may complete most of their iterations or most of their executions, or may even complete their executions also. So, what ultimately thread says is, thread says we don't improve the performance, but we will effectively utilize the time the methods executed. That time will make it effectively utilized, rather increasing the speed of the execution. No mechanism makes method executions speed up, but by simultaneously running, we get a feel like all methods are running along with each other thread. So that is how the one method delay will cause other methods to quickly complete their execution without being impacted on the first thread execution, the delayed execution. That is how system life cycles will be effectively utilized, and quickly the methods other methods execution is completed, but those method executions are not got speed up. That is the point. So for that, in the last video, we saw how to extend from thread, how to implement or how to override that run method, how to start the thread, and all that we saw. In this video, we'll see the second way of implementing thread, that is by implements from runnable interface. By implementing from runnable interface. By implementing from runnable interface. You may surprise how extending from thread class can be a substitution by implementing from runnable interface. One way we implemented thread by extending from thread override and run method. The thread started in the main method, and from the main method the threads started, generate thread and print thread. But the question is how extending from thread can be a substitution by this implementing from runnable interface to implement threads. Remember, thread class is also implemented from runnable interface. And threads says that a class implementing from runnable directly or indirectly will be treated as thread, but not class. By extending from thread, the class becomes a thread. Remember, class by not extending from thread becomes a thread. Class by inheriting from runnable interface directly or indirectly becomes a runnable class. That becomes a thread. Even you extend from thread also, that is implementing from runnable interface. If not, you directly implement from runnable interface. So to make one class thread, implementing from runnable interface is the main point. That you do it directly or indirectly. Indirectly doing means extending from thread. Directly doing means by directly implementing from runnable interface. Now we come to the next. Why do we need to implement from runnable interface instead of extending from thread class? In the previous video, I saw we are developing a graphical user interface application in which our class want to extend from some frame class or form class. That is a primary requirement, that is a primary functionality. And in that, multi-threading, simultaneously executing something else, some graphic image animation or something else, want to be a secondary requirement, secondary functionality. The thread implementation want to be a secondary functionality. Graphical user interface want to be a primary functionality. In such cases, if you extend class from thread, the class which is extending from thread will lose the chance of inheriting from one more class. So let the classes extend from whichever primary requirement class they want, and optionally we ask them to implement from runnable interface. The thread implementation should always be a secondary requirement and second implementation, but should not be a primary requirement. That's what I'm saying. The most important point is in any language, multi-threading is a secondary requirement but not primary requirement. So to implement primary requirement, our class may need to extend from some more superclasses. With that extension, we want to implement multi-threading also. Hence, a class must always implement from thread functionality by not extending from thread class. What? By implementing from a runnable interface. We are seeing that example. So, how by implementing from runnable super interface? Is your doubt. So, number generator class remains same. The previous example, this example, both are same. Number generator class is same. Generate method is same. Print method is same. Everything is same. But in the previous example, what we did for this generate method, we wrote class one class called public class generate thread extends thread. From the public void run method, we called a number generator dot generate method. This in a for loop of 100 times. In order to use this number generator object here, this generate thread class constructor received a number generator class reference. With that we can call generator. Similarly, one more class called public class print thread extends thread. Same way we implemented. Print thread class constructor received number generator class of object reference. Run method from the run method from for loop 1 to 100 times. We called number generator. So my point is not to change anywhere in the implementation. You need not have to change anything here. Except instead of writing extending from thread class, you simply write implement from runnable interface. And you simply change the superclass. Instead of extending from thread, you write implement from a runnable interface. Remaining implementation remains exactly same. In the client, we need to do some small minor changes. See here. Public class generate runnable, implements runnable. And still this class is having chance of extending from one more class. Even after implementing threads also, this class is still having a chance of inheriting from one more superclass. That's the point. So here in the generate runnable class constructor also we are receiving number generator class object. From where we'll receive? From the main method. From here. Into generate runnable and print runnable, we are passing number generator object into the constructor. So that is how we are getting number generator here. With this dot, we are differentiating the class instance variable and constructor parameter. This number generator object is assigned to class number generator class object. And in the run method, we are iterating for loop and calling generate method for 100 times. Why we are calling generate method here for 100 times or 50 times or 500 times is because it don't mean that in threads each method is called for 50 times or 100 times. Where actually methods are implemented, methods are actually implemented in generate and print method. Methods are actually implemented in generate and print method. The point is the logic written in generate method and print methods are in such a way that each method execution may take more amount of time. And their actual execution may take more amount of time. Why more amount of time? Because they may be doing some database operations. They may be writing somewhere into cloud. They may be writing into some network systems. Or they may be writing into mobiles. Or they may write it into some web services, microservices, or file systems, XML, JSON, as I told you before. The actual method implementation lies in generate method and print method. Such each method execution usually takes more time, is what our guess is. So, in order to get a feel like generate method and the print method are executing for more amount of time, after all, one system.out.println statement written in generate method couldn't execute for that much of time. So, in order to show that each method is executing for a lot amount of time, we are calling the generate method. We are keeping generate and print method calling statements in for loop for each iteration for 100 times. 100 times, 100 times. Same example, except implements runnable, everything is same. Coming to the client, there is a slight difference. Here we are passing number generator class object as argument into generate runnable class constructor, print runnable class constructor. And these two classes are now has received number generator class object. Good. That is what we want, because that same object print runnable class print method run method also want to use to call print method. The same object this generate runnable class run method, this generate method calling also must use. The same object both threads must use. In order to do that, we did pass by reference. So after passing number generator object into generate runnable and print runnable, remember these two are runnable interface subclasses. They are not extended from thread. If they are extended from thread class, then in the thread class start method exists. We can directly call number generate thread dot start, print thread dot start. Directly start method can be called. Then these threads will be registered in thread scheduler. From there, run methods will execute. But because these two classes are implemented from runnable interface, in runnable interface only one method exists, that is public but run. That we already implemented here. How can we call start method on this runnable? Hence, we need to pass generate runnable object, and each runnable object now must be passed as argument into one thread class constructor. Here, here into here, here into here. And you pass each runnable object as argument into one thread class constructor, and then call threads t1 dot start and t2 dot start. Then immediately what happens? This generate runnable and print runnable will go to thread scheduler. Because they are registered here, generate runnable and print runnable. From here, the run methods will be called simultaneously. Threads are registered in thread scheduler, and from thread scheduler, the threads are called concurrently by calling run method. So, in this entire compared with the previous example, the only difference I noticed is classes instead of extending from thread, classes are implemented from runnable interface. And second, in the client program, we noticed the main method we noticed that the runnable objects are again passed into one thread class constructor, Thread objects are created like that, and then thread objects are started. So, among the extending from thread and runnable interface, the preferred way of implementing threads is implementing from runnable interface, because so that the inherited classes will still have a chance to extend from one more class. And who are intended not to write thread classes as separate classes. Developers who don't want to write thread classes as a separate classes, they can implement threads as a anonymous classes also. How to implement these anonymous classes? So here we don't write generate runnable and print runnable classes. Directly in the client program itself. Directly in the client program itself, we'll write runnable class object. The runnable class object construction body will directly implement this run method, and from there we'll call generate and print method. We'll see the difference. Runnable anonymous class. See here. Number generator anonymous client, public static void main. First number generator class object is created. Here one small change is required. You can copy paste, compile and run all my programs as this. They won't cause any compilation error or execution error, because all are executed programs. Except here, the object which we are using in the anonymous class, that object or variable must be declared as final. That is how I forgot to declare this number generator class as this object reference as a final. Okay, anyway. So you first create number generator class object, and after that you create one runnable class object, new runnable of. In the object creation body, this is for loop close, this is run method close, this is runnable object close. Main method is not closed, main method is closed here. So you create one runnable object. This entire process is called as one anonymous class. In that object creation body, we are implementing public void run, iterating for loop, and calling generate method for 100 times. Same logic we implemented by creating a runnable object here. In that body, we implemented run method, and from there we are iterating for loop for 100 times and calling print method. So if you do like this, writing separate subclasses for thread or runnable interfaces will reduce, the number of classes will reduce. But one limitation is the code which is implemented here in the thread. If this code do not want to be reusable, if they do not want to be written as separate classes outside directly, then they can be implemented as anonymous classes. Then you pass these two runnable objects as arguments into two thread class constructors, create two objects, and call both the thread objects, t1.start and t2.start. So this is how both the threads are started, but execution remains same. Extending from thread class, implementing from runnable interface, implementing anonymous classes to implement threads, all remain same. Now, so far what we have seen is sequential method execution, one by one method calling, and three simultaneous executions. How? Extending from thread, implementing from runnable, and implementing runnable as an anonymous class. Three simultaneous executions. Sequential execution is completed. Three ways of simultaneous execution is also completed.
Like, share and subscribe. Hit the bell icon for more updates.